Hi guys, on the previous video we spoke about passing in parameters into the orchestrator itself and all of those fun stuff. Now what we wanted to do is actually take it a step further and say, cool, what if we wanted a process that is long running, right? Azure has this thing called eternal orchestration. So it's basically a setup of some sort that basically resets up the solution after the orchestrator has actually finished executing, right? So if we look into what that looks like, essentially code wise, I'll take votes, but I think by now you guys know that Azure does a lot of these things out of the box for us, right? So what I'll do is I'll go to context dot continue as new. Right, what am I doing there? I am effectively creating another instance of my orchestrator. Why? Because I don't want to have a why do I not want to have that? Because this thing will always be in memory, right? When it's in memory, it's effectively consuming resources. So what do we want? We actually want this function to run and basically get to a point that it stops for some time and goes back to its original context. So I should have actually done that. Well, should have done it that way, but taking it that step before I actually show you guys what I'm about to show you. But essentially, being able to run this thing in such a way that it doesn't have a bunch of what do you call this? A bunch of come on loops that consume memory. So essentially that's that. But if you look at what I'm doing here is I'm saying cool, continue as new. It will basically try copy the context that it has there and basically pass in whatever parameter that I'm passing in my next iteration. So if, let's say for example, you are running something that does an increment counter of some sort, this is effectively how you would go around getting to that particular point. So cool. What I'm gonna do here, I'm just gonna add another method here called await context. On my context on itself, I'm gonna create something called create timer, right? My create timer, I'll say cool, run this thing after some sort of time, right? I'm just gonna say UTC time dot, let's say add minutes, and I'm gonna say run this thing every 1 minute, right? Then I'll just pass in my cancellation token, dot none. I need an import using thread, it's fine. So that will basically say cool, hold off this thing for whatever time I've specified. I've said from whatever time this thing got to this point of the code, wait for a minute, then get to running my instance again, right? Then yep, that is pretty fine. So it writes my name, then writes my surname, then I'll just do this so that it creates a bunch of spaces. I hope it does what I expect. Don't write code like this. I'm writing it just to do a demo. So that's that. Essentially, it'll write my surname. After writing my surname, it will open a bunch of lines, then it will execute after some time again. So what I'll do, actually what I should have done is I'll say console dot write line, and I am going to use my time, right? And I'm gonna say date time, and I'm gonna say date time UTC. Okay, right now it's fine. It will show my South African time because I'm recording this video from South Africa. I have that set up on my laptop, but that's fine. So what's gonna happen? We're gonna get into our trigger orchestrator method, which will execute our orchestrator. Our orchestrator will trigger all of this method, then go to sleep for a minute, then basically rerun this particular process. So I'm just gonna start that and say cool, we spoke about replace, so I don't expect any replace here because we are running this all our logic as activities. So the only replay really that's gonna happen is this one and executing the different functions that we have here in our wait method. So cool. Same kind of flow, sending in my name and surname. I am on my entry point, the HTTP trigger function. Then I go into my loop or into my orchestrator. My orchestrator expected to execute all of these functions. Once it has executed all of these functions, it will execute it sometime again. So I've just added what minutes. Let me just say seconds actually. Seconds. At seconds. Then I'm just wanna make it a little bit faster. So I'll just start that there, so that we can see it plowing through. I'll disable all my breakpoints because you guys know the flow by now, that it goes orchestrator function out. Currently it has, at that particular time, it went and said cool, your name is this, your surname is this. Then go for it, come. Waiting for it to execute, making sure that I'm not holding a breakpoint or anything. Come on. Okay, while it's doing that, I'll just look. There's no breakpoint hit yet, so I expect it to go in there, then go into writing my name and surname again because of this continuous new after waiting for 30 seconds. Cool. And if I go here, you see it created a space, wrote my name again. It will continue doing this over and over and over and over until I actually want to terminate. How do I actually terminate? Remember the endpoints that I was telling you guys about? That's where they come into play. Then how do the jobs essentially get queued, or why is my orchestrator being able to basically go to sleep and come back? And if I go here and I refresh, you'll see there's two tables here, right? This is my instance. If you look at my instance ID here, it's effectively what I have on code here. This is my instance ID that I use, right? Then that's effectively that. It has a bunch of tasks and all of that. Then there's another table called namespace instance. It has a bunch of other information in there. Then it uses queues, so it uses test hubs or test hub names, and in there essentially what happens is you have a message that is not visible on the queue until such a point that it has to be triggered. So at some particular point here, you'll probably get a message. Once the function processes, the message basically goes away. So that's what's happening as it does that. So that's essentially the magic behind when the orchestrator knows to retrigger. That's where the magic happens in the storage account. So if I look at this, boom. It's not queuing anything here. I just wanted to show you guys the message, but anyways, it's fine. If I go here, you'll see that it's doing a bunch of writing my name down there, name and surname, refreshing. Oh wow, it's taking forever. Okay, cool. I'm not gonna show you that, and also it seems, but essentially it adds queued messages here. The function picks up the queued message and it knows that cool, I need to basically I need to basically stop executing. So if I go here and I say okay, my function is actually running, so if I go to my body, that is fine, and I go to post, this is instance my terminate, right? I don't need to say anything on my termination reason there, so I'll just leave it as is, and I'm gonna send that in. Boom, 202 accepted, to accepted, I expect, okay, cool, something else happened. What happens? Multiple execution, completed, event found. So basically, because I abandoned my thingy, it basically abruptly said, cool, I'm going out, even if it was on a sleep mode essentially. And what does that do? That effectively kills any orchestrator instance that is executing. So if I put in my breakpoint here, hypothetically speaking, this thing should have stopped already, so it shouldn't hit that breakpoint in forever or until I go back and actually say cool. Or actually a good test for that is I can say cool, don't save that, and I say cool, execute that. You see it's throwing a 500, so that instance is probably running somewhere. If I look at my console, what does it complain about? It says cool, there's an orchestration that is already running, and I want to, oh no, I've deleted my request. But essentially, those add boys that I showed you there, you can use them to basically say, cool, terminate this particular orchestration with instance ID, da 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 da. That's why you kind of don't want to actually get to a point where you are using a dynamic instance ID, because you want to reference it somewhere, someday, I mean. So, cool. That's pretty much what it looks like. And thank you guys for tuning in.